Have you ever pondered over the puzzle of Earth's past and its shifting continents? Imagine the world as a giant jigsaw puzzle, its continents drifting and colliding over billions of years, forming massive landmasses we call supercontinents. Now let's dive a little deeper. What exactly is a supercontinent? Picture this: multiple continents, joined together into one colossal landmass, a sight so vast, it's hard to fathom. From the icy tundras of the Arctic to the arid deserts of Africa, all squeezed into one gigantic piece of land. That's a supercontinent for you. But how do these supercontinents come to be? The answer lies in a theory that has revolutionized our understanding of the Earth: the theory of plate tectonics. Let's break it down. The Earth's crust is like a cracked eggshell, divided into several large pieces called tectonic plates. These plates, floating atop the semi-fluid mantle below, are constantly on the move, albeit at a snail's pace. They slide past each other, pull apart, and sometimes they crash head-on. When they do, they form mountains, cause earthquakes, and yes, they create supercontinents. This process is far from a one-time event. It's a never-ending cycle, a dance choreographed by the forces of nature. Over hundreds of millions of years, continents drift together, form a supercontinent, then break apart, only to come together again in a different configuration. Take a moment to let that sink in. The land beneath your feet, the very ground you call home, has been part of numerous supercontinents in the distant past. It has journeyed across the face of the Earth, reshaped by the ceaseless movement of tectonic plates. From this, we understand that our Earth is a dynamic planet, always evolving and reshaping itself. Today's continents might be tomorrow's supercontinent, a testament to the incredible power of nature and the ever-changing face of our planet. Now that we know what supercontinents are, let's take a stroll down the lanes of Earth's history. Imagine a time when all the continents we know today were merged into one giant landmass, a supercontinent. This has happened multiple times in Earth's history. Let's visit some of these ancient supercontinents. First stop, Rodinia, which means motherland in Russian. It came into existence around 1,300,000,000 years ago. The continents we know today were all huddled together, forming this massive landmass. But as the Earth's tectonic plates shifted, Rodinia began to break apart, a process that took around 300 million years. Next, we have Pannotia, the supercontinent that formed after Rodinia. It existed around 600 million years ago. Pannotia's life was relatively short-lived, and it began to break apart after about 50 million years. It's like the Beatles of supercontinents, a brief, brilliant existence, leaving an indelible mark on the world. Finally, we have the most famous supercontinent of them all, Pangaea. You've probably heard of this one. Pangaea was formed about 300 million years ago. This supercontinent was home to the first dinosaurs and was surrounded by a single global ocean, Panthalassa. But about 200 million years ago, Pangaea began to break apart, leading to the formation of the continents as we know them today. The birth and death of these supercontinents were not random events. They were driven by the Earth's internal heat engine, which powers the movement of tectonic plates. When these plates converge, supercontinents are born. When they diverge, supercontinents break apart. These ancient supercontinents have left a lasting impact on the Earth's climate, life forms, and even the rotation of our planet. The breakup of a supercontinent can lead to changes in the Earth's climate as the newly formed continents move towards or away from the poles. This can cause ice ages or periods of extreme heat. The movement of continents can also create new habitats for life, leading to the evolution of new species. So the story of our Earth is a story of constant change, driven by the forces deep within our planet. And as we'll see in the next scene, this story is far from over. Do you think we're done with supercontinents? Think again. Our journey through the tumultuous history of supercontinents doesn't end with Pangaea. Scientists have proposed a future supercontinent dubbed Amasia that could reshape our world once again. Amasia is not a figment of science fiction, but a projection based on the study of Earth's geological and magnetic history. The theory stems from the observation of a phenomenon known as true polar wander. This is not the drift of continents, but the shift of Earth's outermost layer relative to its rotation axis. Now let's take a step back to understand this better. Imagine you're spinning a raw egg. The yolk, being denser, naturally shifts to the spin axis, right? Similarly, Earth's continents, being denser than the ocean floor, tend to congregate around Earth's spin axis over hundreds of millions of years. This congregation eventually leads to the formation of a supercontinent. Over the past 1.5 billion years, this has happened twice, resulting in Rodinia and Pangaea. Looking forward, scientists predict that the next supercontinent, Amasia, will form at the Arctic, around 90 degrees from the last one, Pangaea. The formation of Amasia is predicted to happen in the Arctic because that's the location of the spin axis. It's like the yolk of our egg, remember? And the continents, like the denser yolk, will slowly but surely migrate towards it. This theory of Amasia is based on the assumption that the pattern of supercontinent formation and breakup is cyclical. But of course, Earth's geological future is not set in stone, pun intended. Many factors such as the movement of tectonic plates, changes in Earth's magnetic field, and even the gravitational pull of the moon and the sun can influence the formation of a future supercontinent. The formation of Amasia is still millions of years away, but it's a tantalizing prospect for scientists and enthusiasts alike. It's a peek into the future, a future that holds within its grasp a new chapter in the epic saga of supercontinents. Why should we care about something that happened millions of years ago, or something that's going to happen millions of years from now? That's a valid question, and it's the one we're going to tackle in this segment. You see, studying supercontinents isn't just about indulging our curiosity or quenching our thirst for knowledge about the past. It's about understanding our planet in a comprehensive way. It's about piecing together the complex processes that have shaped our world and will continue to do so. First off, supercontinents provide invaluable clues about Earth's history. The formation and breakup of these landmasses are significant milestones in our planet's geological timeline. By studying these events, we can gain insights into the tectonic forces at play, the patterns of crustal growth, and the evolution of our planet's structure. But it's not just about rocks and tectonics. The shifting of continents has a profound impact on our planet's climate. For instance, when all the continents come together to form a supercontinent, it alters ocean currents and atmospheric circulation, leading to dramatic changes in climate. Understanding these links can help us better predict and mitigate the effects of climate change. Moreover, the rise and fall of supercontinents have influenced the evolution of life on Earth. The formation of a supercontinent can lead to an explosion of biodiversity, as species are forced to adapt to new environments and conditions. Conversely, the breakup of a supercontinent can lead to mass extinctions, as habitats are destroyed and species are isolated. And lastly, studying supercontinents can offer a glimpse into the future. By understanding the forces that drove past supercontinents to form and break up, we can make educated guesses about what might happen to our planet millions of years from now. Studying supercontinents is like piecing together a massive jigsaw puzzle of Earth's past, present, and future. It's about understanding where we've come from, where we are, and where we're heading. It's about gaining a deep appreciation for our planet's dynamic nature and our place within it. In this journey through time and space, we've explored the fascinating world of supercontinents. We've danced with the Earth's crust, journeyed through the epochs, and peeked into the future. Let's take a moment to recall the elegance of this cosmic ballet. Supercontinents, these colossal landmasses, are the result of plate tectonics. The Earth's lithospheric plates moving, colliding, and coalescing over countless millennia. They are the grand stages on which life's drama unfolds, from the dawn of the earliest organisms to the rise of humanity. We've traced the footprints of ancient supercontinents, Rodinia, the mother of continents that existed over 1 billion years ago, and Pangaea, the most recent supercontinent that many of us might remember from our school days. These giants of the past have shaped the world as we know it today, influencing climate, biodiversity, and even the course of evolution. Looking ahead, we've glimpsed into the crystal ball of geoscience at the future supercontinent, Amasia. Predicted to form in the next 50 to 200 million years, Amasia is yet another testament to Earth's unending cycle of unity and fragmentation. But why should we care about these ancient and future supercontinents? Well, they aren't just fascinating geological phenomena. They're key to understanding Earth's history and future. They've shaped our world's climate, geography, and life itself. By studying supercontinents, we can gain insights into Earth's dynamic nature, helping us predict and prepare for future changes. Supercontinents are Earth's way of telling its own story. They remind us that our planet is a living, breathing entity, constantly changing and evolving. They're a testament to the grandeur of geological time, the power of tectonic forces, and the intricate interplay of land, sea, and life. Supercontinents are a testament to Earth's dynamic nature, a captivating tale of unity, separation, and rebirth on a planetary scale. As we continue exploring the cosmos, let's remember to appreciate the fascinating story of our own home planet told through the dance of continents across the eons.